All right, guys, this is a second clutch out of a 4T65E. It's a little bit older clutch, but it can be used to explain all of the clutches that you'll see in different transmissions. So this clutch, you can see on the inside of it, or this drum, you can see on the inside of it some small holes here. These holes are where the fluid comes in to apply against this piston. So you can kind of see around here, this piston that's around here, and you'll see that when they apply that, it's going to push up this apply piston right here. Now, there's a ring right here. You can see this little snap ring right here. It's holding in some springs. So when this apply piston goes forward, it's against the spring pressure. So these springs will push it back in when the fluid pressure is removed. So what you'll have against this apply piston is what's called a wave plate. Not all transmissions have this, but most of them do. There's a wave plate here that just takes up some room, and you can kind of see the wave back and forth on that. That's going to be the first thing that goes back in. Then you'll have an apply plate. You can see how much thicker this is when I compare it to the steel ones. You can see the thickness of that, almost the size of that screwdriver there. And that's an apply plate for the piston. Next up, we've got a fiber. And you can see there's fiber on both sides of this disc. And you can see the splines are on the inside here. And then I have a steel that you can see the splines are on the outside. And you see the difference in thickness. It's a lot thinner than that apply plate. But we've got a steel, and then it just, as you look across here, it just alternates fiber and steel, all the way till we get to what's called a backing plate. Now you can see this backing plate is mega thick. So we got a pretty thick backing plate. Now anytime you build a clutch, the backing plate is going to be the farthest away from the piston because it has to hold all the pressure from that piston. And then the last thing here, what we hold it all together with, is this snap ring. And you can see this snap ring is a pretty small snap ring. Just kind of holds everything together. So what we're going to do is put all this back together, and then we'll take a feeler gauge and we'll get a measurement of what the end play is of that clutch. Abracadabra. And poof, it's back together. So what we're going to check here is actually the end play. So I can pick this up, and you can see that there is some end play between this. Now, different clutches will have different amounts of end play, depending on if they're on all the time or off most of the time or off most of the time. Usually one that's on most of the time will have less of an end play. One that's off most of the time will have more of an end play so that it doesn't burn the clutch up when it's not being used. But that's just general stuff. So what we're going to do is check end play with feeler gauge. So I'm going to prop this up just a little bit with my screwdriver here, just so I can you can see the movement there, so I can check this end play. Now, this particular clutch for the 4T65E for General Motors doesn't have a spec. They just kind of use basically the size of all the clutches, and then through the computer they can adjust the shifting through that. There are companies out there that want a specific measurement in these clutches to get a good feel for it. One like Sonic's, they expect to have about 5 to 12 thousandths in play in this clutch. So I'm going to use this kind of as a go no go gauge. I've got a 5 thousandths gauge right here along with a 12 thousandths gauge. So what we should find is that the 5 thousandths gauge fits in fine, and the 12 thousandths gauge doesn't fit in. So we'll try with the 5 first here. And like I said, I'm just kind of propping it up so I can get my feeler gauge in here. And you can see that I'm underneath the backing plate and against the clutch here, and I can get that 5 thousandths in no problem. So let's flip over to the 12 thousandths gauge, and we'll try and get that in. That should not go in. Oh no. So we've got some extra in play there. Now, like I said, General Motors is just going to let that go, and they'll adjust it with their computer. But what we could do on some of these clutches is they have maybe a thicker backing plate, or that snap ring that we put in, that snap ring might be a little bit thicker, and all that might push that a little bit further down and reduce that in play and get us the in play we want. So next up, we're going to do a functional air check. Hang on. All right. Now, what I'm going to do is flip this over, and again, remember I showed you the holes that were back down inside here. We can use the support here to actually, where it actually applies the fluid right in here, we can assemble this, and then I can use a hole that applies the fluid with some air to do an air functional check to make sure that when I installed that piston, I didn't cut it when I installed it. So we'll slide this together, and then got a rubber tipped air nozzle here, and we'll go into this hole right here and just apply some air, and you'll hear it clunk. So what you should hear is it kind of holds that pressure in there. And if I applied it and I hear this leaking out of here, then I know that maybe I tore my piston, and I've got to take it back apart. And before I assemble this whole transmission, I want to air check my pistons to make sure that I put them in right and that they're going to hold fluid when they actually apply in the transmission.